Yes, right. Give me maximum 2 3 minutes. So give me a few minutes. Okay. Uh Plan today we are planning to discuss. Today it's a revision about hydrostatics and fluid dynamics only. If we have enough time, we can go with lenses quick revision, but we'll see. We'll see. Time is 7:48. Okay. Mm, right. Okay. So now, right, we'll discuss. Mm, okay. Right. Okay. Right. Okay. Okay. So now, what is the plan today? Now, last week, I think last Thursday, we discussed. Now, this is the week two. Now, in week one, normally, now to give a proper overall experience in revision classes, yes, I do 3 days per week. But students should filter if you require to join, if you need the 3 sessions, if you feel yes I want to join all the 3 sessions, then only I will be able to get the knowledge, then definitely you should join the 3 sessions. If one thinks that no, I can remember the theory points and theory note, I can remember, I want to only join for past paper discussion and paper class, then you can avoid joining the revision and you can join for past paper discussion and model paper writing and marking. If one thinks that no, I have done already past papers, then I only want to join for the paper class, then you should only join for the paper class. You should decide what you really want with your current level, where are you now, whether have you covered the theory points, whether you can remember all theory points, whether coming to this session, whether will it improve myself. That idea should come from your end. You should know which sessions that you want to join and which session that you want to avoid. It's up to you. And also I tell you that always I prefer, if runs join via online, I prefer that. But we know that now normally we are doing 3 days per week: Thursday night, Friday night, and Sunday evening we are doing a paper writing and discussion. Right? Thursday night, Friday night, and Sunday. Right? Sometimes since we are doing 3 days, sometimes you might have other classes because you want to parallelly, you want to do chemistry, biology, combined maths, ICT. So you want to do all those subjects also parallelly. That's obvious. There is no doubt with that. That's obvious. But in case if you feel that joining for today's class might clash my other subject, then you should think the priority which class that you want to attend. Whether if you could not attend for this class, will I able to get the recording from the teacher? You should decide. And in the case of class clash, then definitely you can watch the recording. There is no doubt, right? Because in here we are doing everything properly. Now we are guiding you, we are revising them, and in the website itself you can access the PDF, you can access all the recordings. Right after I do a session, within 2 3 days I will upload the recordings to the platform. So then you have 100% freedom to decide and join for a class. Right? Don't you think that we are doing something big than other class? No. Actually, this is the way of doing a revision class, revision and paper writing. Right? So therefore, you don't think, I don't know, some of you might think that we are doing something big in this class. Yes, obviously we are doing something big only, but these things should be done actually. Right? Paper, other than the paper writing, this revision and revising the theories and doing the past papers is not my job actually. All I told, it's your job. But I felt most of students facing problem when they're revising also, they can't remember, they didn't join for the classes properly, they forgot the lessons. And when they are doing past papers, sometimes they think that they can understand the theory. For an example, hydrostatics, they know that pressure means H rho G, but when it comes to an MCQ essay question, they don't know how to get the answer. So they also want to do past paper questions, but they don't know. They know the theory, but they don't know how to apply with the past paper question, how to get the answer. They don't know. They have no experience. So your part actually I am doing. So therefore it seemed like we are doing so many days, right? Then it will be a problem whether, no, it's not like that. You want to decide what you want. So this revision classes, I say now I'm also putting very big effort for this class actually. Very big effort. 3 days per week, not 3 days also now, because 26 paper class Saturday evening also. I ask you to join for the Saturday evening paper class, because these days we are discussing past paper essay discussions. Then that is much important for 25 people. Right now, yesterday, last week, if you came for the paper class, you understand this 2020 unit 2 mechanics essay question. We took 1.5 hours, around 2 hours we took to discuss that question, essay question. Sometimes, ne? So therefore, 25 people, I don't know how many of you agree or not. I am doing a very big job for this 25 revision class because I really want to do this somehow, because I kept a small goal. Anyhow, I will finish this 25 revision class with my best. And for you, what I tell is, there is nothing wrong in the revision class. I'm okay. We have revision sessions, and when more inputs come from your end, we can do this revision class with much effectively. Then we are doing past paper discussions. Some people think that they haven't tried past papers, they haven't done a single question in past papers, they think that past paper discussion not important. I know past papers by looking at the marking scheme. I will be able to pass papers. I don't know whether that is possible for biology and ICT. But when it comes to physics, you are not able to understand what's there in past papers, right? Then the model paper writing, paper marking. It's a very big load that I'm doing, but because my satisfaction, and there are some students, because of some students only I'm doing that for my satisfaction and because of some students. So therefore, get the maximum benefit. get the maximum benefit, you can feel free to talk with me, right? So when you message me, definitely I reply. You know that people who message me, they know I reply. And you can come, you put your inputs, you can put your inputs, then we can do this as a very good discussion sessions. Okay, that is the first point I want to tell. Okay, don't worry, today we have to learn, today we have to study, don't worry. Then that part is done. The next part, I think tunes, people who shared the people who enrolled early, and I think I shared in the group the address and the names for the students who I'm going to share the tudes for the last week. I think I already shared the tudes. Definitely you should get the tudes this week. I think already you should have got the hands up. How many of you got the tudes already? Hands up. I share the hands up. How many of you already got the tudes? I send the tudes. If you enroll a bit late, I think I have to send another part set of tudes, and also that is the past paper MCQ essay question tude. Anyhow, I will send a workbook tude. It might be most probably on next week. I will send that also. So then, whatever the now I'm preparing now, yet didn't could not post yet, preparing. So the month, we assume there are 4 weeks, right? There are 4 weeks: week 1, week 2, week 3, week 4. So what in week 1, you know that in week 1 what have we done? Normally we know there are 3 sessions, right? In week 1, uh, Thursday, Thursday normally it's 8 to 11 p.m. only. Sometimes I might do at 7:30. Sometimes I might do at because I'm doing it. I'm starting at 7. Sometimes, not always. Normally 8. If I do bit early, I inform in the group. Right, there's a WhatsApp group. You should join for a WhatsApp group. If I'm doing at 7, the reason is to do something big, to give something big. If not, I don't want to do at 7 o'clock. You know that, ni. If I'm starting at 8 or 9 o'clock, then there's a problem in my side. So therefore, if I'm doing at 7, means that's to give, to learn, to do something big, to do a lot. I'm doing. And the normally Thursday classes, I thought to give a quick revision. QR means quick revision. That means we select certain chapters in the. If you came from the class from the beginning, I think you will be able to cover all the units in your syllabus from A to Z. Whatever the important points, what we do in the revision class, we discuss all the important points, right? Sometimes we don't go with the deep explanation, but what is important is the revision. If I go with the deep explanation, it will become a theory class. So what is important, we brief it. And to do past papers and model papers, the important knowledge we quickly will summarize and will give it. Today you will understand how the way that we do hydrostatics and fluid dynamics, right? Normally we take to discuss hydrostatics and fluid dynamics, we take around 1 month, around 4, 8, 16 to 20 hours to discuss hydrostatics and fluid dynamics, but planning to revise that within 3 hours. That's the plan. That's the plan. If we have time, we'll discuss about what lenses also. Normally, Thursday, quick revision, we are discussing a quick summary about 2 chapters, right? Today, unit 2, fluid dynamics, unit 2, hydrostatics. And I additionally put unit 3 lenses also. I don't know whether we have enough time to discuss lenses. I'm not sure. We'll see. We'll see. Then Thursday, Friday, what we do? Friday we are doing right from the chapters that we discuss on Thursday, from in the quick whatever the section that we discussed in quick revision. On Friday, what we are doing, Friday 8 to 11, sometimes 7 to 11, sometimes 7 to 11, 11:30, I don't know. Then we are doing the past paper discussion PPT. Past paper discussion PPT. Okay. Now, mostly here we are doing past paper MCQs mostly to catch all the possible patterns. And also we are doing past paper essays also in here. But so far, I have done past paper MCQs here. Right. So then when we do past paper MCQs, we can catch all the points, right? So then tomorrow we are doing past paper MCQs from unit 2 hydrostatics tomorrow. And the Sunday paper writing, last day we planned to do paper but could not do. This Sunday definitely we are writing the paper, right? It depends. The first day MCQ, no, it's a full mixed paper. Now these are section wise past discussion. When it comes to papers, they are mixed papers, standard mixed papers. Now we are doing now. Normally my way is I will give 2 MCQ papers, then 2 essay papers. That's the way. Right now, currently I plan to give 30 to 35 MCQs for the papers. Right, the next month it will become 50 MCQ paper, 4 structured, 4 essay paper. Right. So then when we are very close to the exam, every week there will be one full paper. That's the way of going. So then I will mark this. So we'll write through online because I was purchased the app, but there's a problem in that app. That's why we could not do last week. This week also not sure. We are writing the paper, but not through that app. But next month we will be able to do the app papers through the app. Then exact time we can write the paper. All right. Then you are writing the paper with a fear, because you know when the time is finished, automatically that website closes. Before that time finishes, you should write the paper. You should upload the paper in the app, in the platform. So then sometimes you write the stress. Then I think we can get a good exam experience. So most probably this month we are not doing that, but we are writing paper through online, through Zoom or something we are writing. So next month onwards we are going shifting for app. We'll see. We'll see. I won't do an effective paper class. Then what? So then marking every week. Every week we are writing. You are writing the paper. I mark it, right? Then I will give marks, right? If you don't like to share your marks in the group, your mark is 10, 12, 15, 30. If you don't like to share in the group, then you request me personally, then I only share to you. But I rank whatever the students available to the revision class. I rank one to this. I don't put the name, only the marks. So likewise we can do something big. So the big part, it's a big work. Now I think we started in January. I think we started with 30 small people. Now I think many enrolled. I'm very happy that some students really supported and shared our classes. So happy, many enrolled in this what we call March. So I'm happy, because I don't know whether you are satisfied or not. Actually, I don't know. February we have done many sessions. So then I think now March we have to go. Last week, first week we revised talk and force equilibrium in Unit 2, and then we revised what, calorimetry. We revised calorimetry in Unit 4. Right, then Friday we discussed past papers from calorimetry. I think we have done MCQs from calorimetry. Then Saturday we have done two past paper essay questions from Unit 2, very standard past paper essay questions, 2014 and 2020 A level. Sunday we had to do the paper, but we could not do. That paper class was cancelled. Right, story is finished. Story finished. Story finished. Okay. Okay. Story finished. Right. Okay. Now what shall we do now? Now what to do? Okay. Right. I'm briefing. Now time is exactly 8. Time is exactly 8:05. 9:05, 10:05. Until 10:05 we'll do the session continuously. 9:05, 10:05 we'll take a break, and we'll do it. Always your inputs are very important, right? So therefore you give your inputs, so then we can do the class effectively. Okay, right. Okay. Now, you know, hydrostatics, the important points, revision. Quick revision into hydrostatics. Now keep your focus. Quick revision. Quick revision. Unit 2. Hydro. Hydrostatics. If you properly focus today's session, tomorrow past paper discussion, you will be able to understand all the past paper questions. Hydrostatics. Okay. This story. It's a beautiful story. It's a beautiful story. Right. Okay. Now, first, before understanding about hydrostatics, mainly we talk about hydrostatic pressure. Then we talk about upthrust. These are the two important points that we learn in hydrostatics. First, we should have an understanding about what is pressure. The pressure means already you know from the previous knowledge. We defined what is force in the previous classes. Now, pressure means simply what is pressure? Pressure. Pressure. The symbol notation is capital P. Notation is capital P. Now let's consider there's an area. area capital A. This area is capital A. And let's say capital F force X, capital F force applied on this area perpendicular to this area. The force applied on this area is perpendicular to this area. Capital F means force. This force is perpendicular to this area. So then we can define pressure means we know the perpendicular force per unit area. The perpendicular force per unit area is what we define as pressure. So pressure means we know pressure means perpendicular force per unit area. Pressure means perpendicular force over area. Then what is the units of force? Force measured in newtons. Area measured in meters squared. Force unit is newtons. Area measured, area unit is meters squared. Then what should be the units of pressure? Pressure means Newton per meter squared. Pressure means Newton per meter squared. If not, we are using Newton per meter squared as we are using. Keep in your mind, this is what we call as pascals. Newton per meter squared. If not, we are calling it as Pascal. Pascal, capital P simply symbol. Unit symbol is capital P simply Pascal. Pascal, I think. I don't know English. Okay, now still I think you are not very familiar with what is pressure. The story is very simple. Pressure means always force per unit area. When you consider 1 meter squared area, what is the force? That is we call as pressure. For capital A area, force is capital F. When you consider 1 meter squared area, what is the force? That is we define as pressure. Okay, this is the story. This is the story. Okay. So when you consider capital A area, the force acting on capital A area is capital F. When you consider 1 meter squared area, what is the force? How do you find? 5 chocolates, 10 rupees. 1 chocolate, how much? 2 rupees. How you get the 2 rupees? 5 chocolate, 10 rupees. 1 chocolate, 2 rupees. How you get the 2 rupees? You divide 10 chocolates by 5. No, sorry. 5 chocolate, 10 rupees. You divide 10 rupee by 5. That means F over A. This F over A is we call as pressure. Now the story is so far clear. Units of pressure, Newton per meter squared, if not Pascal. Then if you find the dimensions of pressure, right? Dimension of pressure, we know pressure dimension. Capital P means dimensions of force, we know MLT minus 2, MLT minus 2. Dimensions of area means you know it's L squared. These stories, if you came with the previous classes, you know this idea. Then dimension of pressure, learn by heart. Learn by heart, ML minus 1, T minus 2. ML minus 1, T minus 2, dimensions of pressure. This story is done. Okay, keep in your mind, pressure is not a vector, pressure is a scalar. The important point is pressure is a scalar. Pressure scalar. You write down all these important points. We are summarizing entire chapter very briefly. Write all these important points that you feel important. Right? Everything is important, you write down. Pressure is a scalar. This is the important part. What else? Now, but in this, by the topic, we understand it is hydrostatics. Hydrostatics. Now, fluid means generally fluid. There are two categories of fluids. We are talking fluid means the fluid means liquid and gases. Fluid means we know. Fluid means the liquid and gases we commonly call as fluid. Liquid and gases we commonly call as fluid. Now in this lesson, mainly we talk about liquids. Mainly we talk about liquids at rest. In hydrostatics, by the name hydrostatic, that means hydro means liquid, static means constant. Hydrostatic means we are talking about the characteristic of liquids at rest. Fluid dynamics, we talk about the characteristics of liquid and gases under motion. Fluid dynamics, liquid and gases under motion. So that chapter is something different than this chapter. So we are talking about liquids. That story also done. Now then, okay, then we should understand what does it mean by liquid pressure, right? So you know that if I explain this liquid pressure, right? Next story is liquid pressure. Next idea, liquid pressure. First of all, you should understand how liquid pressure forms at a point in the liquid. You should have a brief idea about that. You should have a brief idea how liquid pressure forms at a point on the liquid. Right? Let's consider a container. A liquid is filled into that container. A liquid is filled in the container. Okay. Before they going to that, so we'll talk about, before talking about liquid pressure, we'll talk about some other characteristics also. Okay. Before going liquid pressure, now you know that there's a sample. So you know what is density. I think we learned the definition already. You know what is density, but we learned the definition of density in this lesson only. Density means, you know that density. So density means symbol is rho. Sometimes we are using simple d also, but mainly we are using rho. Rho is the symbol. Rho is the symbol. Now just consider, now I hope you know what is mass and what is volume. You know that, right? So there is an object. This object's mass is simple limb. The volume, in order to occupy simple limb mass, the volume occupied by the object is capital V. Mass and volume, simple limb and capital V. Now what is density? Same story. For the V volume, mass concentration is simple limb. Amount of mass stored in V volume is simple limb. When you consider unit volume, 1 meter cube volume, what is the mass stored in 1 meter cube volume? For V volume, mass simple limb, 1 meter cube means how much mass? How do you find? For 5 chocolates, 10 rupees. 5 chocolate, 10 rupees. 1 chocolate, how much? 2 rupees. 10 rupee over 5, 2 rupees. M over V. This is what we define as density. Always keep in mind, density means mass per unit volume. So you write on, if you want, density means write on the mass per unit volume. Mass per unit volume. Right? Mass per unit volume. So density symbol is rho means MOV. MOV. It's an important equation. Important equation. Mass unit is kilograms. Volume unit is meter cube. Kilograms. Volume unit is what? Meter cube. What should be the units of density then? Kg m minus 3. Kg m minus 3. So density is a scalar. Density is a scalar. And next point is dimensions of density. Dimension of density means mass dimension is capital M. Volume dimension means, you know, length into width into breadth. Volume dimension means L cube, ml cube. Dimensions of density, we know that m L minus 3, ml minus 3. But in hydrostatics, we are talking about relative density, if not we call specific gravity. Relative density, if not we call specific gravity. Density, if I, for an example, if I give you mass of the object is let's say 5 kilograms. Mass of the object is 5 kilograms. Volume of that object is let's say 2.5 meter cube. 5 kilogram mass, volume is 2.5 meter cube. What is the density of the object? What will be your answer? You divide mass 5 kilogram, volume is 2.5 meter cube. Then the density will be 5 over 2.5 means just 2 kilograms per meter cube. That's the idea. But in fluids, when we deal with liquids, we are talking about specific gravity, if not relative density. This is something new. Specific gravity, relative density story is something new. Now, this is a kind of a revision, not a theory class, right? Specific gravity, if not relative density. We are doing this to understand tomorrow's session. Specific, relative density, specific gravity. Specific gravity, if not, the famous word is relative density. Relative density, these are same. Relative density. The symbol is normally we are using capital S. Capital S. Density symbol is rho. Rarely we use simple D. Specific gravity or relative density we are using capital S. Okay. So what is the specific gravity? If not relative density, it is defined as like this. This means capital S means, remember, always when you divide density of the considering object, when you divide the density of the considering object by the density of the water, density of the considering object, when you divide by density of the water, this is what we call as specific gravity of that object, if not relative density of that object. Okay. So we'll do some sample question. Okay. So then you should understand now. If I ask you, do you think, raise your hands, how many of you say this relative density has units and some density of the object that you are considering when you divide by density of water? Raise your hands, how many of you say specific gravity, if not relative density, has units and some? We know they don't have units because density unit kgm minus 3, density of water units also kgm minus 3. When they cancel out, there isn't any unit for specific gravity, right? Do you think specific gravity have dimensions? No dimensions also. So important point regarding specific gravity relative density is no dimensions, no units. Important point is scalar, no dimension, no units. No units, no dimensions. Right? Is the story. For an example, also remember density of the water. Normally, density of the water, unless they specifically given a question, right? Unless they specifically tell density of the water, always we consider 1,000 kilograms per meter cube. Density of the water is always 1,000 kilogram. Keep in your mind, 1,000 kilograms per meter cube. Kilograms per meter cube. Okay, this story. Just remember this value, 1,000 kilogram per meter cube, and also rho W. Okay, rho W. In upcoming sections, you should remember density of mercury, right? Only the two densities you should remember is density of water is 1,000. Density of mercury learned by heart 13,600. You understand density of mercury is larger than the water. It is not important. Okay, later we'll write down density of water 1,000, 1,000, 1,000, 1,000. Okay, right. So far story is finance up. This story is pressure defined. Liquid pressure didn't define yet. But we talked about density. Then we are talking about relative density. These are the stories that we discussed so far. Story we discussed so far. So far story is okay. So far story is fine and so far story is fine. No issues. No issues at all. No issues. Everything is okay. Everything is okay. Right. Then what's our next target? Then our target is right. Then our target is okay. Right. Okay. 819. Okay. Right. So we'll do a sample question. Okay, quickly we'll do a sample question. So you also write down a sample question quickly. Sample question quickly. SQ sample question quickly to understand the story. To to keep in our mind, sample question write down quickly. Relative density of an object is 20. Relative density of an object is 20. Relative density of an object is 20. Find the density of the object. Find the density of the object. Find the answer. Find the density of the object. Find the density of the object. Find the density of the object. Okay. Raise your hands. How many found the answer? Found the answer. Found the answer. So directly you can tell that now. Relative density means when you divide the density of the object by density of water, right? Relative density is 20, density of water is 1000, density of the object will be 20,000 kilogram per meter cube. That's a story. Okay. So then if I do the sample question, okay, is Q. So I can use the equation. Capital is they have given relative density is 20 must be equal to density of the object. Actually, I don't know. Density of water we know it's 1000. So therefore we know this is a right. Rho means how much? Density of the object is how much? 20,000 kg minus 3. Now you know what is a mixture. This story is done. Then we'll talk about when we add two different liquids. Then, for an example, now liquids we can talk about two types. One is miscible liquids and immiscible liquids. Miscible liquid means we know that when we mix two different liquids, they mix well. For an example, what these milk farmers they do to get the high what profit, they mix water with the milk. Why? Because once they mix water with the milk, sometimes we can't identify a big difference. But now there are equipments to identify how much amount of water is mixed to the milk. But what happens there what happens, this milk and water they are miscible, they mix very well. So but there are some liquids, when you mix the two liquids they don't mix very well each other. The best example is you might have experienced when you mix coconut oil with the water. When you mix coconut oil with the water, you know that coconut oil separates with the water. Normally coconut oil comes up than the water. So water is at the down, coconut oil is at top. So why they are not miscible? Now we are talking about when you mix. So when you mix miscible liquids, when you mix two or three miscible liquids with each other, what would happen for the density of the mixture? What would happen for the density of the mixture? Right? I am not going in detail, but I summarize it and I will give it. Right? You just learn by heart those things you learn by heart. When you mix two or different miscible liquids, how to find the density of the mixture? A quick summary. Right? So then here what we can do here. Here what we can do. Right? Now here summary. Now we can mix two or three different liquids into a mass ratio. For an example, if there are two liquids, for an example, okay. Now this liquid is let's say liquid A. This liquid is liquid B. You mix these two liquids into a mass ratio. That means you are adding 5 grams from liquid A, you are adding 20 grams from liquid B, you are going to mix with each other. What is the total mass of the liquid in your mixture? 20 plus 5, 25 grams. Because mass remains same, mass can't change. If you add 5 grams of liquid from A, 20 grams liquid from B, the mixture mass will be 25 grams. 25 grams. Okay, we can't change. So this is we call as we are mixing liquids into mass ratio. What is volume ratio? Volume ratio means when there are two liquids, liquid A and liquid B, you are mixing them with the volume ratio. You are adding 5 meter cube from this liquid. You are adding 20 meter cube from this liquid. When you mix these two together, the mixture will be what? Formed due to the volume ratio. So I am going to draw a small table. I'm going to draw a small table. We can't do the derivation, but this final equation is more than enough to get the idea. Okay. Now a big table. From this knowledge, you will be able to understand tomorrow's all the past paper MCQs. Okay. Until 8, I told you what 8 but 10 5. Until 10, 10 5, keep your focus. Right. Okay. Summary about mixtures. Summary about mixtures. Here, this class, we are not deriving. We don't have to derive it. But what is important in the end, what you should remember? So we are briefing and we are giving. If you mix liquids to a mass ratio, you also draw with me. I don't give separate time. So what are the things I write in the board? Quickly write in your book. Right? Until you get the tute. Okay. So when you mix liquids into a mass ratio, mass ratio. Other one is you are mixing liquids to a volume ratio. Mass ratio is 1, volume ratio is 2. Volume ratio. Now here we can mix two liquids. Normally in your exams they give two liquids. When you mix two liquids, the mixtures, and they give when you mix three liquids, the mixtures. Okay, right. So when you mix two liquids, two immiscible liquids into mass ratio, okay. Again, I can break into two. I can break into two liquids. That means I tell that according to mass ratio. For an example here, let's consider now liquid A. You consider now you know liquid A, you know the mass and density of liquid A, you know. This is your liquid A. You know mass and densities. So now because you are going to mix two liquids, two miscible liquids into a mass ratio, then you know the mass, how much mass that you are going to add from liquid 1 and how much mass that you are going to add from liquid 2, that you know the mass and you know the density. If it is coconut oil, density of coconut oil normally 890 something. If it is water, density of water is 1000. So then mass ratio, mass of this liquid is, let's say, simple M1, density of this liquid is rho 1. Okay. So you are going to mix this with liquid 2. Liquid 2. So you also write with me. Mass and density of this liquid, you know, this mass is M2. Density of this liquid is rho 2. So when you mix them together, we know there will be a mixture. Am I correct? When you mix them together, there will be a mixture. Right? Mixture mass. What will be the mixture mass? What is the total mixture mass? We know simple M1 plus simple M2. So in exams, what they do, they tell that they give two different liquids. They tell water and coconut oil. The water and coconut oil added mass of 5 grams of water and 10 grams of coconut oil added together. They think they mix well. They will ask what is the density of the mixture. They have given density of the coconut oil and density of the water they give. They will ask from you what is the density of the mixture. Then what is the equation you want to use? You want to use, remember, the equation is learn by heart these things. Because in the exam, when you start to derive it, then you can't do an MCQ. Right? The equation is rho equals M1 plus M2. Rho equals M1 plus M2. Rho equals M1 plus M2 over M1 over rho 1 plus M2 over rho 2. M2 over rho 2. Right? This is the equation. So you learn by heart, take a short note. I think if not, this note is more than enough, but better you prepare a short note. This is the equation. Right? If you know the masses, if you know the densities, if you want to find the density of the mixture, this is rho is mixture density. Yeah? This rho is mixture density. This is the equation. Right? Sometimes they might tell that mass taken from liquid 1 and mass taken from liquid 2, they are same. When the masses are same, remember, that means M1, M2 are same. If the masses are equal, if M1 and M2 are equal, so we can write down this equation as, if they have given masses are equal, you can write down this equation as 2 over 1 over rho 1 plus 1 over rho 2. 1 over rho 1 plus 1 over rho 2. Story. This is the equation. Okay. If the masses are different, mass taken from liquid 1 and 2 are different, this is the equation. If the masses are same, you took 5 grams and 5 grams, 5 gram liquid from 5 grams of mass from liquid 1 and 5 grams of mass from liquid 2, then if the masses are same, this is the equation. This is the equation. So we'll do one to sample questions. Right now, when you, rather than, if you are mixing 2 liquids, when you mix 3 liquids, when you mix 3 liquids, so when you mix 3 liquids, then how do we find the density of the mixture? Now there are 3 liquids, okay? 1, 2 plus this black color liquid, mass M3, density rho 3. If you are mixing 3 liquids, how do you find the density of the mixture? How do you find the density of the mixture? Then the equation is what? Rho equals, if there are 2 liquids, M1 plus M2. If there are 3 liquids, M1 plus M2 plus M3. Over M1 rho 1 plus M2 rho 2 plus M3 rho 3. This is the equation. I think I don't have that much of space here. In that case, I will write here also, okay? But when you are writing, write into a proper order. This is the equation. Now, this is the quick summary about the things. But when we start deriving this, we take hours of time. We don't have hours to discuss derivations. Our target is to remind them and as soon as possible do some standard questions. In here also, if you are mixing equal masses from all 3 liquids, 1, 2 and 3, simple limb, if the masses are same, then the final equation will be rho equals density of the mixture equals 3 over, if there are 2 liquids, 2. If there are 3 liquids, 3. 1 over rho 1 plus 1 over rho 2 plus 1 over rho 3. This is the equation. We want to talk about liquid pressure. But before that, this is also important part of hydrostatics. Right? So then if I ask you, okay, hands up, now whatever I have done here under mass ratio, everything is clear answer. Do you really understand what I'm saying? Now what I have done is, if you want to find the density of a mixture, when you mix 2 liquids together, how to find the density of the mixture, I am giving direct equation. Hands up the story. Do you understand what I'm doing? Okay. I think you all understand. If not, act like you understand. Can't discuss detail. Okay. Volume ratio. In theory classes, we discuss these things. Why, how these derivations comes from the beginning to end. We discuss it here. We can't do that. We are doing a revision. We don't have time now. See 8:35. We have done half an hour. So we have another half an hour or 45 minutes to complete hydrostatics. Then the break. Then the what? Fluid dynamics. Okay. Volume ratio also same. I think I don't get enough space, but it's okay. In volume ratio also, I'm going now in case in the exam, if they ask you 4 liquids, but they don't ask 4 liquids, in the case if they ask 4 liquids, how to find the density of the mixture? M1 plus M2 plus M3 plus M4 over M1 rho 1 plus M2 rho 2 plus M3 rho 3 plus M4 rho 4. They don't ask 4 liquids. They don't complicate like that, because they have different ways to make you complicate. Again, I'm considering two liquids. If you mix into a volume ratio, so then two liquids. Again, three liquids here. We'll see the space. Again, two liquid means right. This time you are mixing liquids into a volume ratio. Now here you added based on the masses. Now here you are going to add based on the volumes. This liquid volume density is rho 1, volume is V1. This liquid volume is V1. Density is rho 1 plus this liquid volume is V2. This liquid volume is V2. This liquid volume is V2. The density is rho 2. So when you mix them into a volume ratio, mixture, when you add them, mixture, how do you find the density of the mixture? The equation will be, now I write here, the equation will be, write down, the equation is, learn by heart. The equation is rho 1 V1 plus rho 2 V2 over V1 plus V2. The equation is rho 1 V1 plus rho 2 V2 over V1 plus V2 if there is two liquids. Right? This is the equation. In case if they mention, now for an example, you took 5 meter cube from liquid 1. You took 20 meter cube from liquid 2, 5 and 20. Then V1 is 5, V2 is 20. Density of water 1000, density of the current oil 850. This story. Right? In case if you take equal volumes, if you are taking equal volumes, when the volumes are same, when V1 and V2 are equal, when V1 equals V2, then you can write down density of the mixture means what? Keep in your mind rho 1 plus rho 2, over 2, V1 over 2, right? So this is the 2 days lesson. Within half an hour, 2-day lesson. Normally we take 2 days to discuss this story. Within half an hour we have done. If you come to 26 theory class, we took around 2 days to discuss this part by doing all the questions. Here we are not doing standard questions. It's a revision class. So now want to consider 3 liquid story also. Now 3 liquid story, I think I don't get enough space, but it's okay. 3 liquid. From this knowledge, I am pretty much sure you will be able to understand all the past papers. All the model paper discussion, you will be able to understand. Right? But only thing is you should work from this knowledge. You should also start doing past paper discussions. You should also start doing past papers. And then you should revise the theory that you already learned. It's your role. V3, rho 3, mixture. I write the equations here. Mixture. Now hands up. How now can predict, right? Now do I want to write? Just think, if you mix the liquids, 2 or 3 liquids into mass ratio, density of the mixture means M1 plus M2, M1 over rho 1, M2 over rho 2. When the masses are same, 2, 1 over rho 1 plus 1 over rho 2. When you mix 3 liquids, here M1 plus M2, if there are 3 liquids, if there are 2 liquids, M1 plus M2, if there are 3 liquids, M1 plus M2 plus M3. M1 over rho 1, M2 over rho 2, M1 over rho 1, M2 over rho 2, M3 over rho 3. Here 2, here 3 liquid means 3, 1 over rho 1 plus 1 over rho 2 here, 1 over rho 1 plus 1 over rho 2 plus 1 over rho 3. Now same thing. Okay, now forget about that. Now volume ratio. Volume ratio, when you mix two liquids, density of the mixture will be rho 1 v1 plus rho 2 v2 v1 plus v2. If you mix three liquids, tell me the equation. If you mix three liquids, rho 1 v1 plus rho 2 v2 plus rho 3 v3 plus rho 3 v3 over v1 plus v2 plus v3. Am I correct? If you mix three liquids, rho 3 v3 now ni v3. The story. Now here, if you mix three liquids, rho 1 plus rho 2 plus rho 3 over 3. Rho 1 plus rho 2 plus rho 3 over 3. Hands up the story. Quickly write down you that point, write down. I don't have space there. Hands up, the story is very clear. So far, hands up. Story is very clear, hands up. So far, story is very clear, hands up. Now the story is done. Can understand? The story can understand. Okay, this is the revision about the first part of hydrostatics. Is the revision. So you should understand what is pressure. Then density means what. Relative density is very important story. Then when you mix the liquids into different ratios, what would be the density of the mixtures? Now we'll do one or two sample questions. We don't have time. We'll do one sample question, two sample question from mixture part, and we are going back to the liquid pressure. Okay. So now write down the sample question. Write down a sample question. A sample question. Write down. A sample question. Write down. A sample question. Write down. Okay, no need to write down sample question. I just put in the board, quickly get the answer. Shall I erase this one? Okay, I put here. Now there are three liquids. Okay, there are three liquids mixed into. Now see how many of you can do it. So there are three liquids. So liquid one is density is, let's say, 1000 density. Yeah. Liquid two density is, let's say, 1500. Liquid three density is how much? 2000. They mix into mass ratio. This mass simple limb, this mass 2 simple limb, this mass 3 simple limb. Quickly find the density of the mixture. When you mix three liquids, three masses, quickly find the density of the mixture. Three liquid means this equation. Mass ratio means this equation. Find the answer. Once you finish finding, I don't want to get the final answer. I only need the substitution. Once you substitute it, get the answer. Sorry, once you substitute, find, raise your hands. Once substitute, raise your hands. Okay. Once you finish, raise your hands quickly. Substitution only. Give me 1 minute. I'll be back. Substitution ni. Here m plus. Okay, if I do it, okay, I'll do in this space and erase it. Then density of the mixture will be here. What? M1 plus M2 plus M3 over that equation. This equation. M1, M plus 2 simple, M plus 3 simple M over M over 1000 plus 2 simple M over 1500 plus 3 simple over 2000. Now what will happen here when you take simple M common factor out? Now here 3 plus 2 plus 1 means 6 simple M. 6 simple M. When you take simple M common factor, you can write down 1 over 1000 plus 1 over 2000 plus 1 no 3000. Here you can cancel out simple limit term. Hereafter simplification is there. That is your job. 6 over 6 over 1 no 1000 plus 1 no 2000 plus 1 no 3000. This is a simplification. You should do that one. Okay. Right. Sometimes they give like this. They give, there are two liquids. Now, sample question 2. Sample question 2, you guys try to do like this. Sample question 2. Sample question 2, you guys write like this. Not right means I erase this one. In sample question 2, here they have given two liquids. We are mixing these liquids into a volume ratio. Volume ratio is 1 to 2. 1 to 2 volume ratio is 1 to 2. Density is 1000 and 1500. Find the density of the mixture. Then I don't do so many sample questions. Now this is theory revision to catch, to get an idea. We are doing 1 to sample questions and we are entering next part. Hands up who got the answer. If they have given volume ratio 1 to 2, if you want to find the density of the mixture, what will be the answer? If you get the answer, raise your hands quickly. If you get one, good, very good. No one. One got the answer. Quickly. Done. Done, right? Not a big stuff. Not a big story. Story simple. Now volume ratio means you are having should goes here. Volume ratio, two liquids, one, two liquid means in this column, two liquid. Mixture means volume ratio means there are two volumes are different. If you take 5 meter cube volume from liquid 1, you are taking 10 meter cube volume from liquid 2. That's why they have given volume ratio is 1 to 2. 1 to 2. So that means volumes are different means is the equation. Rho 1 V1 plus rho 2 V2 over V1 plus V2 equation. So what you do here, what you do, rho, density of the mixture, rho m, rho 1 means I can say 1000 into V1 volume. V1 means they have given a volume ratio. So therefore, what you can do, you can write down this volume is 1 meter cube and you can think this volume as 2 meter cube for an example. Then 1 plus rho 2 means 1500 into 2 over V1 plus V2 means 1 plus 2, 3. If you simplify, you get the answer. Story done. First part of the hydrostatic story done. I'm revising that part. I think I revised everything properly. So now we know the pressure. Pressure means simply when you provide a force to a perpendicular area, right? By using your hand. Let's say now to this whiteboard. Let's say your surface area of your hand is let's say 50 centimeters squared. 50 centimeters squared. By using your hand, let's say you provide a force the whiteboard, you are applying a force on that 50 centimeter squared area. Then the board particle feels a pressure. Pressure means simply force per unit area, force per 1 meter squared area. When you consider 1 meter squared area, what is the force? That is pressure. When you consider always 1 meter, no, one chocolate, how much rupees? That's a story. One chocolate, how much rupees? Let's say when I was doing grade 9, chocolate, Kit Kat, Chit Chat, not Chit Chat, Kit Kat. Kit Kat is 5 rupees. One chocolate, 5 rupees. 1 meter squared, how much force? That is pressure. 1 meter squared force, pressure. Now, the next story is liquid pressure. Our scenario is liquid pressure. I'm erasing everything. Erasing everything. Okay. 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 Some points. So liquid pressure means, first of all, I'll draw a liquid. I will draw a liquid. This is the free liquid surface. Free liquid surface. It can be water or it can be any kind of liquid. Right. Now, just think this is the atmosphere, air. A liquid, just consider water in your glass. This is the free liquid surface, free water surface. This is your water. Now, when you consider a point capital A on the liquid, we say that this point capital A feels a pressure. When you consider a point in the liquid, we say that point feels a pressure. Now, from the pressure story, we know pressure creates when there is a force acting on the area. Now, we might be wondering, in a liquid, how pressure at point A forms. There is no doubt that when you consider an object on the table, mass of the object is simple m, then weight is, mg. Newton's third law, normal reaction force on the object capital R upwards, normal reaction force on the table capital R downwards. This story. So because of the weight of the object, there is a normal reaction force acting on the table perpendicular to table. This normal reaction force, what? Compressing the table, creating a pressure on the table. So if I ask you why pressure is formed on the table, due to the weight above the table. Same story is here. Why point capital A feels a pressure? Because of the liquid particles above this point A. From free liquid surface to this point capital A, because of all the liquid particles above point A. Because of the weight of liquid particles above point A feels a pressure. Right? Just think you are the point A, when a set of your friends, right, climb on top of you. Now you are sleeping, one guy is what? One guy is climbing on you. The force that you feel, the pressure that you feel. Another guy is on that guy. Then now there are three, there are four, five. When the people on top of you is high, what the force, the pressure that you feel is a story. Okay, this is a story, pressure. Now, pressure equation. We are calling uh, this pressure as hydrostatic pressure. Now, this depth, normally we measure depth from free liquid surface. This is free liquid surface. FLS means free liquid surface. You write down free liquid surface. Depth is h, density of the liquid is rho. We know gravitational acceleration is g. Gravitational acceleration g. So in a liquid, if you want to find the liquid pressure, the most popular equation in mechanics, P equals h rho g. If you want to find the, rather than telling if you want to find the pressure, if you want to find the hydrostatic pressure, the pressure produced only due to the liquid, the pressure produced only due to the liquid, the hydrostatic pressure we can write down P equals h rho g. Now you know what is h. Always h measured from the free liquid surface to the point that you are considering. The most popular equation, P equals h rho g. P equals h rho g. Now in theory classes we derive this equation, but here we don't derive. No need to also. They don't ask in your exam to derive this. Some model papers they can ask, but exams they don't ask. Most important equation. Now you know, you won't define, you should know what is h. The vertical, h means always vertical. The vertical height from free liquid surface to the point that we are considering. Rho means density of the liquid, g means gravitational acceleration. Okay, gravitational acceleration. Okay. But there is another story. This is case one, hydrostatic pressure. This P means I write down hydrostatic pressure. So this is case one. Okay, this is case one, hydrostatic pressure. Okay, hydrostatic pressure. Okay, hydrostatic pressure. Sometimes, but we know that on top of the liquid there is air. On top of the liquid, there is air particles. There is air particles. Because of air particles, there is atmospheric air pressure, atmospheric pressure. There is atmospheric pressure. So, in a question, if they ask you to find the hydrostatic pressure at point capital A, only H rho G. But sometimes they ask you to find the total pressure, if not absolute pressure at point capital A. So I consider the normally we know if you have done in chemistry, normally we consider atmospheric pressure is 10 to the power 5 Pascal. Atmospheric pressure means the symbol is pi, not atmospheric pressure symbol is pi. Pi means atmospheric pressure. You write down properly. Atmospheric pressure, pi means atmospheric pressure. Normally, atmospheric pressure is, keep in your mind, 10 to the power 5 pascals. So if you want to find the absolute pressure at point capital E, absolute pressure, if not, we can call it as total pressure also. So we can call it as total pressure. Okay. Then the equation will be absolute pressure P capital A, if not P total, whatever. Hydrostatic pressure plus hydrostatic pressure, hydro pressure at point capital A plus atmospheric pressure. Atmospheric pressure. Atmospheric pressure. Right? You write down properly. Atmospheric pressure. The equation will be PA means H rho G plus pi is the equation. Story done. Now pi means atmospheric pressure. The value is 10 to the power 5 pascals. Normally 5 means 10 to the power 5 pascal. Normally keep in your mind pi means 10 to the power 5 pascals. That story is done. This story done. What's next? Okay. Then characteristics of pressure. I want to teach you that story. Effective density. Yes. Okay. Right. Okay, give me a few minutes. Give me a few minutes. Okay. So then I will give a quick brief about the units used to measure pressure. Sometimes, all the time, they don't give, let's say, pressure at a point in the liquid as they don't give always 500 Pascal. They don't give in Pascal. Sometimes they give in different units. What are the units that we use to measure pressure? Now, from this theory, pressure means Pascal is a unit. Newton per meter square means same unit for Pascal. In addition to that, they can give pressure in bar, torr, ATM, mercury centimeter, mercury millimeter, mercury meter, water meter. If they have given water millimeter, water centimeter, these are the units to measure pressure. In case if they have given, but this is the standard unit, Pascal is the standard unit. If they have given a pressure in other units, you should be able to convert into Pascals. So therefore, we'll talk about how to convert that story. So then we'll talk about the characteristics of pressure in a liquid. Then we can go to the upthrust story also. Okay. Time is 9 o'clock. I think we started at 8 5. 55 minutes we have taken. 55 minutes we have taken. Maximum within half an hour, we want to finish the hydrostatic story within half an hour. All without missing all the important points also. Okay. Right. Okay. Now units. Now when it comes to units of pressure, now you know that Pascal, if not Newton per meter squared. So we are using ATM as a unit. We are using bar, mercury millimeters, mercury centimeters, and then mercury meter. Mercury millimeter, mercury centimeter, and then mercury meter, water, water meter, water meter, water meter, water centimeter. So I will tell you how now. Okay, keep in your mind. If you want to convert ATM or bar, they are same. If you want to convert ATM or bar, ATM, if they have given a pressure in ATM or bar, if you want to convert to Pascal, roughly, yeah, if you want to convert to Pascal, you should multiply by above 5. Should multiply by above 5. Let's say 5 ATM. If they are asked 5 ATM, convert to Pascals. 5 into above 5 Pascals. Right. The next one is, if you want to convert mercury millimeter to Pascals, right? If you want to convert mercury millimeter to Pascals, so you don't ask why, we can't teach you why. Mercury millimeter Pascals, what we want to do is you want to multiply by, first of all, you want to multiply by 10 to the power minus 3. Then you want to multiply by 13,600 into 10. Okay. Now, normally 13,600 means density of the mercury. 10 means here gravitational acceleration. Okay, if they have given mercury millimeters and if you want to convert to Pascal, multiply by the power minus 3, then again multiply by 13,600 into 10. Right. So if you want to convert, 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 let's say now mercury. Now, based on this, you know how to think about conversion of mercury centimeters to mercury centimeters to Pascal. You know how to do that, but it's okay. If you want to convert mercury centimeters to Pascals, multiply by the power minus 2. Multiply by the power minus 2 into multiply by 13,610. Multiply by 13,600 into 10. Now I think you understand. Milli to meter means what? Milli to meter means minus 3. Centimeter to means minus 2. Rho G. Rho G. If you want to convert mercury, if you want to convert mercury meters to, if you want to convert mercury meters to Pascal, only multiply by 13,600. Now here mercury meter, not meter, here mercury meter. Mercury meters to Pascal, multiply by 13,600 into 10. 13,600 into 10. If you want to convert water meters to Pascal, okay, normally they give water meters, okay. This is also they have given in the exams also. If you want to convert water meters to Pascals, multiply by density of water 1000, multiply by 1000 into G. G means 10, gravitational acceleration. So this knowledge is more than enough to do anything, any conversion. Now I will tell you some characteristics of hydrostatic pressure. I will tell you some characteristics of hydrostatic pressure. Then plan is to stop before 9. Now 9. Now time is 9:05. 1 hour. It's been 1 hour. Still we have to finish lots of things. Now the important points in hydrostatics. I will brief it. Now keep in your mind. Okay, first stories. First important point. Point number one. IP. Important points IP. Important point IP. Point number one. Okay. I just seem like we can't finish the lenses part, I think. IP1. IP means important point number one, right? Important points. Important points. Important points. Number one. Now keep in your mind hydrostatic pressure in a liquid at a point doesn't depend on the shape of the container. Doesn't depend on the shape of the container. Okay. The point number one is I will draw a diagram. I will explain a diagram. So you also draw the diagram with me. Now let's say now just consider now you pour a liquid to this container because you know when you pour a liquid, that liquid will evenly distribute on all these three shapes and all these three containers and the liquid level. Now if you have the experience, you understand when you fill liquid to this container with different shapes, the liquid is what equally fill in all three containers. So you can't see in one container liquid level is like this container liquid level is like this container liquid level is like this. You don't see, you can't see. Or when they are filling, they fill with the same height. So once you filled, once you filled, okay. If I draw the liquid, this is your liquid. Okay. So this is your liquid. Your liquid. Same liquid, huh? The first point is keep in your mind. Let's say when you take any point in the same horizontal level, right? In the same horizontal level, when you take any point in the liquid, the first important point, right? In this horizontal level, I take 3 points. This point is point capital, this point is point capital B, this point is point capital C. Now we're very clear, these 3 points are the same horizontal level, right? We know point A, point B, point C at the same horizontal level, right? Point A, B, C at same horizontal level. Keep in your mind always. Then free liquid surface is also same in all three containers. Point A, point B points in the same horizontal level. The vertical height to point capital A from free liquid surface is a simple h. Vertical height from free liquid surface to point capital B simple h. Simple h. So therefore, what will happen? The pressure at point capital A, point capital B, point capital same. Same liquid, same density, H rho G, H rho G, H rho G. So therefore, keep in your mind, the first point is when the pressure in a point in a liquid does not depend on the shape of the container. That's the idea, right? So it always depends only with the vertical height to the free liquid surface to that point. So pressure at point A, point B, point C. This is first story. Point one. Sometimes we might be thinking like this. We might be thinking, sir, okay, even now let's take same depth, but I am taking one small container and I am taking another large container. Just take about water glass and just take about your water tank. So from the free liquid surface, from the free liquid surface to certain height depth, certain depth, let's say 5 centimeter depth from free liquid surface. If I take a point in the water glass and if I take the point in the water tank, then the pressure will be different, right? No, then also pressure is same. Then also pressure is same. The second point, keep in your mind. The second point is this is a small container. Okay, this is a large container. If your depth is same, if the liquid is same liquid, density same means pressure can't change. Pressure remains same. Okay, next story. I think 1 hour and 5 minutes. So I take 2 points, point capital A and point capital B. Same. The depths are same. This is also simple H. Point capital B. Point capital A. This depth is simple H. Same liquid density rho rho. Same liquid, same density rho rho. It doesn't matter how much amount of liquid is in your container. If the depth is same, the free liquid surface to this point depth is same. Density same means keep in your mind pressure is same. That is first point. And next story is what will happen for the pressure when you go more and more deep. The most important point. Point number 3. When you go more and more deep, what will happen for the liquid pressure? Right? What will happen? You take a container and you are pouring a liquid. It can be water, it can be whatever. You are pouring a liquid. This liquid is completely filled. And what you do using your kind of very sharp tool, you are creating some holes on the container, top to bottom. You are creating some holes in the container. Then what will happen for the liquid? Liquid will leak through those holes. Right? At this point, let's say point capital A, this level point capital A, this level point capital B, point capital C. Right? When you go more and more deep into the liquid, we know that pressure is high. Why? The hydrostatic pressure equation is H rho G. Density, same liquid means same density only. G is same, but H different, right? So when you consider pressure at point A, height is let's say H1. When you consider point B, height is what? H2. The depth is H2. H2 is larger than H1, right? When you consider point C, the depth is what? The depth is H3, the greatest. So we know height larger means the pressure also. Pressure at point B is larger than pressure at point A. Pressure at point B is larger than pressure at point A. Pressure at points is largest. This story. Very important point. So when you are going more and more deep into the liquid, keep in your mind hydrostatic pressure and also the total absolute pressure also increases, because absolute pressure means atmospheric pressure plus hydrostatic pressure. Atmospheric pressure remains same, but when your hydrostatic pressure increases with the depth, total pressure also increases. That's the story. This is the point number 3. So likewise, we have a few more points, then upthrust. Then we can finish this hydrostatic story. Based on this knowledge, we can do anything, right? Okay. So now, right now, the fourth point is golden point. I think golden point. Uh, so golden point. Here also I said, but here That idea is mentioned here also. But here it talks about a shape. The golden point, what you do, write down red color pen important. The golden point, red color pen important, write down. The hydrostatic pressure at any point in the same horizontal level. The hydrostatic pressure at any point in the same horizontal level. The hydrostatic pressure at any point in the same horizontal level in the same liquid are same. 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 Right. Already I explained that point here, but separately we'll discuss. That's a golden point in your in hydrostatics. The golden point. Now you can clearly see, now I explained already, but see these point capital A, point capital B, point capital C, these 3 points are in the same liquid water or whatever. And they have the same horizontal, these 3 liquids on the same horizontal level in same liquid. Then they are telling the pressure at point A, pressure at point B, pressure at point C should be same. I explained here also, but here I want to depict that pressure in the same level doesn't depend with the shape, but here pressure in the same liquid, same horizontal level, pressure must be same. That story. Okay, so these are the main stories. Then when you do questions, we do YouTube stories. Then air mixture. Next point is, now fluid means not only the liquid, right? Fluid means a gas also. Now just consider, when you put a gas, it can be any gas, hydrogen, oxygen, nitrogen. When you put a gas into a container, keep in your mind, if you put a gas into a container, we know that gas is spreading through the container. Right? You don't see, if you put into a bottle, you don't see that gas is only storing like this. Gas is what? Distributing throughout the volume of the container. What we consider, now keep in your mind, when there is a gas in a container, when there's a gas in a container, so I draw gas particles. This is gas. It's a gas. When you consider any point in the gas, let's say point capital A, point capital B, point capital C. When you consider any point in the gas, we consider gas pressure is same. But when it comes to the liquid, when you go more and more deeper in the liquid, hydrostatic pressure increases. But when it comes to a gas, when you consider any point on the gas, pressure is same. PA equals PB equals PC equals PD. Story. Okay. The next point is, when a gas is in contact with a liquid. Next point is, when a gas is in contact with a liquid. When a gas is in contact with a liquid. When a gas is in contact with a liquid, 0.5, I think 0.6. This is 0.6. Now see, in this container, there is liquid and gas both. This is your liquid. This is your gas. Now liquid, gas. This is your gas. This is your gas. Liquid and gas. Tomorrow, possible discussion. And tomorrow we are starting gravitational field unit 5 theory class. Not revision, theory class. So if you want to find the pressure at a point in the liquid, point capital E. Let's say gas pressure is P naught. I told you, any point on the liquid, any point on the gas, any point in the gas, we know gas pressure is same. Okay. If you want to find the pressure at a point in the liquid, If they have given density and the height, we can write down pressure at point A. Means we know the hydrostatic pressure at point capital A, depth H, rho G, plus gas pressure is P naught. Okay, gas pressure P naught. If you want to find the pressure at point capital B, where is point capital B? My point capital B is at the interface of liquid and gas. Keep in your mind, point capital B is at the interface of liquid and gas. If you want to find the pressure at point capital B, that is always equal to gas pressure. This story is important. I think this is what mainly you want to know, learn. You want to know this hydrostatics. Then thereafter, when there are 2-3 liquid story also finish. Last point. The last point. Then we'll talk about upthrust. Last point. Then we'll talk about upthrust. I think we took 1 hour and 50 minutes so far. 50 minutes we can finish. Last point. Where to write? Okay. I write here. The last point here. When there are many liquids with different densities, liquid should not be miscible, liquid should be immiscible. Now liquid should be immiscible. The last point 7, immiscible liquids. Immiscible liquids. The last point, immiscible liquids. Immiscible liquids. This is liquid 1, blackish. Height is, let's say, H3. Density is rho 3. This is the second immiscible liquid. Height H2, density rho 2. This is liquid 1. Story finished. Then upthrust, story finished. Liquid 1. H1 rho 1. H1 is rho 1. In the exam, what they do, they give a set of immiscible liquids like this. They will ask you to find the pressure at point capital A somewhere here. They ask you to find the pressure at point capital A. This is the atmosphere. They will ask you to find the pressure at point capital B, point capital C, point capital D. If you want to find the pressure at point capital A, you want to look what is above point capital A. What is above point capital A? Only the atmosphere. Then pressure at point capital A means atmospheric pressure phi. Am I correct? If they ask you to find the pressure at point capital B, you want to check who are above point capital B. Above point capital B, red color liquid is there. Atmospheric pressure is there. Red color liquid, atmospheric pressure. How do you find the hydrostatic pressure produced by the red color liquid? H1 rho 1 G plus phi. Okay, story. Last one. Okay, point capital C. Above point capital C, how many liquids are there? Blue, red, and atmosphere. Then blue means H1 rho 1 G. Hydrostatic pressure produced by blue means H1 rho 1 G. Hydrostatic pressure produced by H1 rho 1 G means red. Hydrostatic pressure produced by the blue one is H2 rho 2 G plus phi. Likewise, story is the overall idea. Genuinely hands up now. Up to now, everything is crystal clear. Hands up. Story revision. It's a revision. It's not a theory class. It's a revision. Again, I'm telling crystal clear answer. We take 4 weeks to do this part. Revision. Everything is crystal clear. Within 1.5 hour, everything is in brief. Story clear. Hands up. Story is clear. Story is very clear. Okay. Now what shall we do now? Now we want to talk about upthrust. You want to drink some water? You guys don't want to drink some water? Okay. So we'll finish upthrust and we'll drink some water. We'll finish upthrust and we'll drink some water. That's good. But I drink some water. Okay. The last part. Upthrust. 9:30, 9:35, we are stopping this discussion. about hydrostatics. Okay. Not big story upthrust, very small story, but they will ask questions in different way. Okay. Wait. I'm erasing everything. It's a good revision. So you will understand because tomorrow when you do past papers, when you do model papers, if you didn't learn this, so if you could not remember, you will remember everything and you will understand everything. This is very suitable for people who learned, who could not understand, who learned, who forgot, who didn't learn. This is very important. Anyone can get the benefit. But planning to cover everything, it's a big plan. There are plenty of chapters. January we have done somewhat, February we have done, March we have done. So we'll try to do our best. Last one, upthrust. Give me 1 second. After doing upthrust, we'll take a break. Okay. Now we talked about liquids. So I will draw a liquid. Liquid. Look here. Liquid here. Is a liquid. Now story is very simple. When you immerse an object fully or partially. When you immerse an object fully or partially. So I immerse same object. Okay, this is my object. Right? This is my object. Density of this liquid, let's say rho. Rho means density of the liquid. You write down. When you're writing, rho means density of the liquid. The volume of this object, is let's say capital V. Volume is capital V. Density of this object, not the liquid, density of the object, just take it as rho S, or whatever. Now what happens, I told you, when you go more and more deep into the liquid, I told you, pressure difference, there's a pressure change. When you consider a point here, pressure is low. When you consider a point here, pressure is high, liquid pressure is high. So because of that, what will happen? There will be an upward force. So because of the pressure difference, now here low pressure, here high pressure. Because of the pressure difference, there will be an upward force acting on the object. Whenever you immerse objects in the liquid, always there will be upward force due to the pressure difference. Due to the pressure difference, there will be an upward force. That is what we call as upthrust. Okay. Now, it's not compulsory to fully immerse your object. You can partially also immerse your object. Right? Now, upthrust means that's an equation. Upthrust popular equation, you know that U equals V rho G. U equals V rho G, the most popular equation upthrust. U equals V rho G. U equals V rho G. Now, people don't understand what is V. That's the problem. Most of you don't know what is V. Keep in your mind, V means submerged volume of the object. Not the volume of the object. V means keep in your mind. Submerged. If not immersed volume of the object. Submerged volume. And some people don't understand what is rho. Rho means density of the liquid where we immerse the object. Rho means density of the liquid. Some people think that rho means density of the object. Rho means write down density of the liquid where we immerse the object. G means gravitational acceleration. G means gravitational acceleration. If I ask you now the thought, now this is the volume of this object is 5 meter cube for an example. 5 meter cube for an example. Now these two objects, same object, 5 meter cube, 5 meter cube. This immersed volume, this immersed volume is how much? Now I tell half of the object is immersed in the liquid in the scenario. Half of the object is immersed in the liquid in the scenario. Reply everyone. Total volume of the object is 5. Reply everyone's at box. V. What are you going to substitute for V? What are you going to substitute for V? Reply everyone. What are you going to substitute for V? Reply everyone chat box. Ace Academy. You want to reply for Ace Academy, not Suleiman Nawaz. What are you going to substitute for V? You want to reply for Ace Academy. Oh no. I told. Reply everyone. What are you going to substitute for V? The volume of the object is 5 meter cube. What are you going to substitute for V in this scenario? When half of the object immersed in the liquid. When half of the object immersed in the liquid, what are you going to substitute for V? V should be 2.5. 2.5. It's not 5. It's 2.5 instead of the liquid G. I think this knowledge is more than enough. More than enough. Upthrust story, pressure difference. It's enough. This knowledge is enough. I will teach you apparent weight, real weight to the questions. Finished. 1 hour and 25 minutes. Now just refer the note also. If you have a note, what you do, you take, you compare. So when you refer your note, your theory note, all the important points, I think, all the important points are here. I think within this 1.5 hour, we start at 8:05, 1 hour and 20. We'll take it as 1.5 hour. Within 1.5 hour, whatever the theory points important, we explained everything within 1.5 hour. Normally we do in theory class for what? 12-13 hours we are doing. Genuinely hands up. Hydrostatics revision is done, but we learn more in past papers. Then we learn deep stuffs in model papers. Is the way. Beginner level, then what? Intermediate level, then what? Pro level, low, premium level, or whatever, hard level. So here we give a basic, then we put everything into our mind in the past papers. When you do model papers, we are going in deep. When it comes to theory class, we do hard questions theory class. Here we can't do questions or anything. Here revising past paper. Main this is past paper based revision. Because if you know the past paper means you can get A. Because I did only past papers and I got A. So therefore past paper more than enough. People, I don't know why people underestimating past papers. They don't do past papers. They never done past papers. They might only have done the last 5 years paper. That's enough. They are seeking model papers without doing the last 30-year past papers. The papers very closer to A-level paper are the past papers. But they don't mind about doing past papers. Doing past papers. I also can do. I have many past paper books also from 1982. I have the marking scheme. They always underestimate doing past papers. They don't get 50 out of 50 also when they do the paper by their cell phone. They can't do an essay. They can't even read and understand an essay question their own. But they underestimate past papers. I'm wondering why. If a student have done last 30 to 35 year past papers, and if the student is telling it's and the student scores, and the student scores in the very first time at least 90 out of 100, then yes, he is okay. Yeah, model paper writing is important. Yes, model papers want to practice hard papers. No, students, they don't do past papers. They never done past papers or past discussion. No, it's not good, not suitable. Wrong story. I think story is done. I think you guys raise your hands. Genuinely, this hydrostatics revision, crystal clear answer. Hydrostatics revision, crystal clear answer. Crystal clear. Crystal clear. So reply everyone how long you want the break. Then we'll discuss fluid dynamic revision. How long you want break? Reply everyone chat box. Want reply for Ace Academy. Reply everyone how long you want.
Reply everyone in the Ace Academy chat quickly. Reply me. Reply how long you guys want the break. Reply how long you want. 15. 9:35, 9:40, 9:50. Come at 9:50 or 51. No, 52. Come at 9:51. Take your break and come.
Uh, yes, right. So now this knowledge is enough. So when I do questions, I will tell you YouTube. There is no theory or any point related to YouTube stories. But when we do past paper questions, then we'll discuss YouTube scenario theory point. There is no specific theory points regarding YouTube's. So then this is the overall idea. Overall idea. So when I do past papers, if I feel some points are important, I will discuss in there. Okay, that is there. Right. So then now we'll start doing question, not question. We'll start doing this. What? We'll start doing fluid dynamic story. Maximum I will do the class 11, 11:15. Give me 1 second. Right. Okay. So now fluid dynamics. Here story is we talk about fluids under motion. We talk about fluids under motion. Right. Quick revision. Fluid dynamics. Okay. QR. Unit 2. Fluid dynamics. Now comparing with the content in hydrostatics, fluid dynamic content is not that much big. So there are only two equations in fluid dynamics. One is continuity equation, other one is Bernoulli's equation. That is the overall content. But we talk about some applications. But I will okay, fluid dynamics. Now in here, what to be known? Now, first, you should have an understanding about what is mass flow rate, what is volume flow rate. That idea you should have. Now, mass flow rate. Okay, mass flow rate. Mass flow rate. The symbol is we are using simple m dot. Simple m dot is mass flow rate symbol. Simple m dot. Then what is mass flow rate? Now just think about there's a tap. There's a tap. So there's a tap. Right? There's a tap. Now assume the liquid, a liquid is flowing. A liquid is flowing to the tube. A liquid is flowing to the tap. Liquid is flowing. Okay. Now let's say now you are collecting that liquid into a container. You are collecting that liquid into a container. So within simple t time period, the mass of the liquid collected in the tank, the mass of liquid collected in the tank, let's say simply, within simple t time, mass of liquid collected in the tank is simple. So you can tell within simple t time period, within simple t time period, the mass the liquid collected is simple lim. What is mass flow rate? When you consider 1 second unit time, what is the mass of the liquid flow? Now within simple t time, simple m mass of liquid collected to the tank means within simple t time, simple m mass of liquid flown through the tap. Within simple t time, simple m mass of liquid flown through the tap, right? Within simple t time, simple m mass flown means Within 1 second, what is the mass flown? That is mass flow rate. 5 chocolate, 10 rupees. 1 chocolate, how much? 10 rupees over 5 m over t. So we call, when there's a liquid flow, within 1 second, what is the liquid flown through a certain cross section? That is what we call as mass flow rate. So keep in your mind, mass flow rate. Sorry, mass flow rate means m dot. Mass flow rate means m dot. Keep in your mind, mass flow rate means the mass of the liquid flown through the certain cross section within 1 second. Simple m over t. Okay. I think this story you understand this equation. Now we can remember we just now we learned if you the relationship between mass volume, the relationship between mass volume and density. What is the relationship? Mass over volume is density. Mass over volume is density. Right. So then keep in your mind, we can write down mass as m over v equals density. You know, mass means we can write down volume in density. Okay. Okay, I will discuss that later. Now this is mass flow rate. Then what is volume flow rate? Now, if you understand what is mass flow rate, you can understand the volume flow rate easily. Within 1 second, what is the mass flow and mass flow rate? Within 1 second, what is the volume flow rate? Am I correct? So then, give me an equation for volume flow rate. Volume flow rate. Volume flow rate. The symbol is Q dot. Normally we are using Q dot. Because volume is V, when you put V dot, it can be a small issue. Therefore, we are putting Q dot. Volume flow rate Q dot. Some normally V dot we are using to what velocity stories also. We use the symbol Q dot. Now same story. Just think same tank within simple t time. You collect capital V amount of fluid. Within 1 second, what is the volume of the fluid collected? If within simple t time, volume flown is V, within 1 second, what is the volume flown? Within 1 second, what is the volume flown? That is volume flow rate. That is the volume flow rate. Okay, therefore you can write down within simple t time, volume flown is V meter cube. Within 1 second, what is the volume flown? That is V over simple t. This is volume flow rate. So the equation for volume flow rate, you know, Q dot equals volume over time. Volume over time. Okay. Right. Okay. But keep in your mind, there is another equation of volume flow rate means volume over time, but there is a popular equation of volume flow rate. There is a popular equation of volume flow rate. Normally, volume flow rate means keep in your mind. Popular equation is we can write down volume flow rate as if you know the velocity of the liquid flow. If you know the velocity of the liquid flow. Now here V means a volume. Here V means volume. So I write volume as V dash. Volume as V dash, okay? I write volume as V dash. Just think if you know the velocity of this liquid is V. Velocity of this liquid is V. Think in that way. The cross-sectional area through which this liquid flows capital A. Keep in your mind, we can write down volume flow rate as Q dot means keep in your mind. The most important equation for volume flow rate is cross-sectional area into velocity. Cross-sectional area into velocity. Now here V dash means volume. Here V means velocity. Don't you confuse, okay? So this is the most popular equation in volume flow rate. Okay? Volume flow rate means cross-sectional area into velocity. This is the important equation. Now in most of the time when you do in the current equation also, you will see that volume flow rate means cross-sectional area into velocity. Not volume over time also correct, but mainly we are using this equation. Now, okay, Now what you can do, mass flow rate means from these stories, you can do something like this. I can derive also. Mass means what? Volume and density. Mass means m dot means mass means mass over volume means density. Right? So m means what? M means volume into density. Okay? Volume into density over time. Now V over now volume is V dash. Volume is V dash. Volume over time means it's volume flow rate. So you can write down mass flow rate means density into V dash over T means volume flow rate. I don't want to derive it. This is also good equation. So likewise, we can take some equations. So now I think you understood what is mass flow rate, what is volume flow rate. You understood. Mostly we need this volume flow rate, the volume over time. If not, cross sectional area into velocity. You write down what is A, what is B. You write down. Okay, if not, you forget it. Cross sectional area into velocity. That story so far clear. So far everything is fine. So far everything is fine. Okay, that is done. So now the next thing is continuity equation. What is continuity equation? Right. Continuity equation. There are some conditions to apply continuity equation to a fluid flow. Okay. There are some conditions to apply continuity equation to a fluid flow. Next important part is continuity equation. Continuity equation. Careful listen story. A quick brief. Now, right. So you can apply continuity equation for a lamina. Now the problem is you don't know what is lamina and turbulent. I told you in liquid flows, there are two types of liquid flows. Okay. Liquid flows, there are two types of liquid flows. Okay. Liquid flows. One is lamina flow. Lamina. Other one is turbulent. One is lamina flow, other one is turbulent flow. Lamina, if not, we call it as streamline flow. If not, we are calling it as streamline flow. Okay. Other one is turbulent. I will quickly brief it. What is the difference between laminar flow and turbulent flow? Normally, laminar flow means regular, slow, regular, slow fluid flows. Normally, we consider laminar flow. Right? In a laminar flow, streamline flow, that liquid is smoothly, nicely flowing, very slowly, regularly flowing. If I draw a small cross section, if I draw a laminar flow, all the liquid particles are moving in one direction very smoothly. What is turbulent? Turbulent means we know irregular flow. Generally, high fluid flows are irregular flows, turbulent flows. Turbulent. So we can go in detail about this, but it's not a time to go to detail. What is important? I summarize it. Turbulent, laminar turbulent. But turbulent means, remember, irregular, high speed. Irregular, high speed flows. Okay. For an example, when there is a turbulent fluid flow, the liquid particles are moving random directions. The liquid is flowing to one direction, But when you go to the liquid particle scenario, they move in random directions, not they move in the same direction. If I draw a small cross section about a turbulent flow, so this is turbulent. Liquid particles move in different directions near randomly. Some of them go like this, random motion, turbulent. So normally keep in your mind, continuity equation we can apply only for lamina. Lamina, if not streamline flow, I will tell you what is streamline later. You can apply lamina. Next one is incompressible flow. Incompressible fluid. That means you can't compress that liquid, right? You know that air means if there is an air in the container, what we can do, if just think there's a piston, and when you put air into the piston syringe, by providing a force, you can compress the air volume. Likewise, when you are applying continuity equation for a liquid, keep in your mind the flowing liquid. Now, I told you in fluid dynamics, we are talking about the nature characteristics in a flowing fluid, flowing liquid, flowing gas. Then those gases should be incompressible. By providing a force, we should not compress the fluids, compress the gas or liquid. The second condition is incompressible. Incompressible. Immo, I don't know. Incompressible. Incompressible. The next one is homogeneous. Homogeneous. Homogeneous means, what is the difference between homogeneous and heterogeneous fluids? Homogeneous means same fluid, same nature. Right? Homogeneous means same fluid. One place there is only water, other place there's a mixture of milk and water, other place there's a mixture of milk, water, coconut oil. That is heterogeneous fluid. The particle nature at any point is not even. When these three conditions satisfy, the continuity equation says that in that fluid flow, when you consider any point, if there is a fluid flow, liquid or gas flow, if that fluid is laminar, incompressible, homogeneous at any point, when you consider any point on the fluid flow, mass flow rate is constant. Therefore, volume flow rate is constant. Okay, that is what continuity equation says. Okay, let's consider. I will draw a fluid flow. Carefully listen. I'll draw a fluid flow. We'll draw a fluid flow. You also keep on writing. Okay. So now you can see this is a kind of tube. Now this is a wide region and narrow region. If you consider cross-sectional area of the wider region of the tube, we'll mark it as capital A1. Cross-sectional area of the wider region is A1. Cross-sectional area in the narrow region of the tube, let's mark it as capital A2. Just think through this tube, just imagine laminar, incompressible, laminar, incompressible, homogeneous fluid is flowing. This is A2. Right? There's a fluid flowing. Then I want to teach you what is streamline. Okay, look here, streamline. Streamline means what? Here we frequently talk about streamline. What is streamline? What is streamline? Now we know enough. Just think there is a liquid flowing in a tube, in your PVC pipe tube. Water is flowing through that PVC pipe tube. Water is flowing through that PVC pipe tube. Okay. So then when you only track one water particle, the path that the water particle travels is we call a streamline. Now there are millions of particles in the water line, but if you are tracking only the path of one particle, this is the path traveled by that one particle.
So this is what we call as streamline. The path traveled by one particular, when you track the path of one particle, streamline. So the first important point is, if you want to find velocity of that particle at a point, let's say this point capital A, you want to find the velocity, then what you should do, you should draw a tangent. When you draw a tangent at point capital A, that tangent represents the velocity at point capital A. If you want to find the velocity at B, not important that much. If you want to find the velocity at B, if you draw the tangent at point capital B, that tangent represents the velocity at point B direction. Now, keep in your mind, if it is laminar flow, keep in your mind, streamlines never cross. If it is laminar flow, streamlines never cross. There are millions of particles moving in a tube. If it is a laminar flow, there are millions of streamlines. They never cross each other. Streamlines never cross. Never cross. All right, never cross. Never cross. Okay, never cross. Never cross. Okay. So now, if I draw three streamlines for our understanding quickly, if I draw three streamlines, this is horizontal streamline is like this. Okay, a horizontal streamline. This would be the horizontal streamline line. If I draw the streamline, that streamline would be like this. This streamline would be like this. Okay. So now you took two cross-sectional areas. If I mark the velocity, of the fluid at wider region, let's mark it as V1. If I mark the velocity of this fluid flow at this narrow region, velocity is V2. Okay. Now, story is very simple. Now, I'm going to explain what is continuity equation. Continuity equation, three conditions are there. There's a tube, wide region, narrow region, cross-section areas A1, A2, velocity is V1, V2. What is the volume flow rate? Reply everyone. What is the volume flow rate at this region? Reply everyone's at box. What is the volume flow rate at the wide region? Reply everyone. What should be the volume flow rate at the wide region? Reply everyone. What should be the volume flow rate at the wide region? Reply everyone. Quickly. Need your support. Need your responses. Need your response. Right or wrong? You should reply to Ace Academy that you want to chat to Ace Academy. Only two answers. Only two answers. Only two answers. What is the volume flow rate at wide region? Specifically, I told you volume flow rate means AV, A1, V1. Right? Volume flow rate at narrow region, A2, V2. Keep in your mind, continuity equation says that if this fluid flow satisfy these three conditions, keep in your mind, volume flow rate at any point in the fluid flow, volume flow rate same. That means volume flow rate here, Q dot 1 equals volume flow rate here, Q dot 2. This is 0.1, this is 0.2. That means A1 V1 equals A2 V2. This is continuity equation is A1 V1 equals A2 V2. If not Q dot 1, but we don't use this Q dot 1 story. We are mainly using this equation. Right, continuity equation. Okay, this is one story. Okay. Story is, I think, very clearly. I hope you understand. This is the story. So far, stories, fluid dynamics, we talk about mass flow rate, volume flow rate, then laminar, turbulent, and their characteristics. What is streamline, then continuity equation, this one. So far, story is okay. Story is very clear. Hands up. I can go in deep and I can explain, but we know that this is not a time to explain deep. You understand, right? Because in theory class, we are taking time and we explain, but here we can't go in deep. Then we can't do a revision. Reply everyone. If you understand everything, hands up. Okay, if you understand, raise your hands. Only 7. Right? Only 7. 8. Story. Story is okay. This is the story. Then what stories? Lot of stories. It's a theory class. No, 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 no. See, it's a revision class, but we talk theories. So, okay. What else? Laminar turbulent. That story done. This is done. Me. Continuity equation. All the fluid dynamic questions you will understand. We apply two equations. One is continuity A1 V1 A2 V2. Other one is Bernoulli's equation. I will tell you that also. 10:20. We started the class at 9:55. We took around 25 minutes. Uh, 11. I think if it is possible, I will stop at 11. If not, I might do until 11:15. So maximum, you are going to stay with me for last 55 minutes. Right, in the QR session, you are going to stay with me for this week only for 55 minutes. Therefore, keep your focus. Today, I think we are not able to do that. What uh, optics story, but it's okay. We'll see. Right. Okay. Mass flow rate, volume flow rate, current in the equation we know. So we can do. Shall we do a sample question if you need? But we will do in sample question also. We can do. Okay. So I will tell you another story, and I will quickly go to the Bernoulli's equation. Before Bernoulli's equation, we'll do one sample question, a small sample question. Now this story is very clear. Now we can talk about pipelines in two different ways: pipelines in series and pipelines in parallel. So then we'll try to understand what are the important points that you want to know when the pipelines, when they have given more than two pipelines. So here also we can point out, see, okay, I could not tell one important point. Now, please, what would you think about the velocities V1 and V2? Now, you understand volume flow rate same. Volume flow rate same means just think any point, even it's a wide region, no, narrow region, no, volume flow rate same means what will happen when the cross sectional area decreases? What will happen with the velocity? Raise your hands. When cross sectional area decreases, velocity increases. When cross sectional area decreases, raise your hands. Someone if you say the velocity should be increased, answer. Velocity increases, answer. It increases. Therefore, keep in your mind, larger cross section means keep in your mind smaller velocity. When cross sectional area decreases, velocity increases. Keep in your mind. When the cross sectional area decreases, velocity increases. This is story. So when you consider A1 and A2, A1 is larger, A2 is smaller. A1 is larger, A2 is smaller. So therefore, V2, because smaller cross section means large velocity. Therefore, V2 is larger than V1. So this common sense also you should have an idea. Right. So then pipelines in series and parallels. Pipelines in series and parallel, that story. Then we can talk about continuity Bernoulli's equation. Pipelines in series and parallel. Pipelines in series and parallel. So we can talk about pipelines. Pipelines of fluid or whatever. Series. So we can talk about pipelines in series. Now series. Just consider two different pipelines, different cross-sectional areas connected in series. So if I draw the pipelines, if I draw a pipeline, okay, there's a fluid flow. Okay, there's a fluid flow. cross-sectional areas, let's mark it as this cross-sectional area. Okay, there are three pipelines in series. There are three pipelines in series. Okay. Okay. Uh, let's mark. Let's mark this point is point 1, and this point is point 2. Okay, this point is point 2. This point is point 2. This point is point 3. This point is point 4. So then corresponding cross-sectional areas. This is A1, this is A2, this is A3. So you know the stories when pipelines are in series, the summary. What will happen when cross-sectional area decreases, velocity increases, right? Okay. So the first point is, throughout the pipeline, when the pipelines are in series, keep in your mind, throughout the pipeline, volume flow rate is constant, right? So volume flow rate through this region is, let's say, Q dot 1, if not Q dot, 1. Volume flow rate to this region is Q dot 2. Volume flow rate to this pipeline 3 is Q dot 3. They all are same. That is what I told you. When you consider any pipeline in series, volume flow rate same. So you can write down Q dot 1 equals, first point is, you can write down Q dot 1 equals Q dot 2 equals Q dot 3. That is first point. There's another point you want to remember. You want to remember another point is there. That point is, that means A1 V1. That is A1 V1. If you know the velocity is V1. Velocity here, I don't know, the diagram is going, it's a bit messy. You manage it. A1 V1 equals A2 V2, A3 V3. A3 V3 story, And also look here, I want to tell you, when the pipelines are in parallel, I think most of you don't know this part. When the pipelines are in parallel, okay, parallel, something like this. There's a pipeline, a wider pipeline breaks into two sub pipelines. Will think like that. There's a pipeline. This pipeline breaks into two sub pipelines. If not, breaks into three sub pipelines. So this cross-sectional area is what? A1. This pipeline cross-sectional area is A2. Cross-sectional area is A3. A4. Velocity of the fluid flowing through A1 cross-sectional area is V1. A2 cross-sectional area is V2. This is a brief summary. When in theory classes, we learn everything in detail. Here V3, velocity of fluid is V3. Here V4. We can't discuss theory, okay? So, now see, now these three pipelines are parallel. Now, can I tell now, A1 V1 equals A2 V2 equals A3 V3 equals A4 V4? We can't say now like that. Why? Because now this water supply, this water volume is distributing. Now there are three tanks. There are three tanks. The water supply is distributing. Then how now? Now let's say you are supplying 10 meter cube water. You are supplying 10 meter cube water. It breaks into three sublines. Then the water passing through the subline will be 2 meter cube. This is 3 meter cube. This can be 5 meter cube. Then is it 2 meter cube equals 10 meter cube? No, right? So now that law is breaking. When the lines are parallel, we can't tell this volume flow rate equals to A2 V2O, A3 V3O, A4 V4. But we can tell the total volume flown through these three pipelines. Am I correct? 5 meter cube, 2 meter cube, 3 meter cube. Total volume flow rate, total volume of water flown through these three pipelines must be equal to this pipeline volume. So therefore, we can write down here volume flow rate of pipeline 1. I say Q dot 1. Volume flow rate of pipeline 2, Q dot 2, Q dot 3, this one Q dot 4. I can write down Q dot 1. This is important. MCQs they have asked. I can write here. I will write here. Okay, I will write here. Keep in your mind. Volume of the, now just think that whatever the volume comes here should go on in these three pipes. So when you consider total volume went through these three pipelines equal to this volume. Q dot 1 equals Q dot 2 plus Q dot 3 plus Q dot 4. That means A1 V1 must be equal to A2 V2 plus A3 V3 plus A4 V4. This is the story. The story. Genuinely hands up to now everything is crystal clear. Hands up. Crystal clear. Story is crystal clear. Story crystal clear. Hands up. Story crystal clear. Everything is very clear. Okay, this is very clear. Then what? Then shall we do 1 to sample questions? Then from this, I think yes. Then we can talk about Bonelli. So when you do MCQ essay, you will be very familiar with these tools. Now we are only learning the important theory. Sometimes you don't know how to apply this into a question. You don't know. Tomorrow when I do the discussion, you will understand more. Okay, right. Now we can do a question, sample question. I only have a boneless part to be discussed. Sample question, what we can do here. Right. Sample question. Sample question can give also. So we'll do past paper questions tomorrow. We are doing tomorrow. We'll revise it today. Okay. We'll revise it today. Okay. We'll revise it today. 10:30. 8:05. 20-minute break. Around 20-minute break. 25. 20-minute break means. So you are going to stay with me for maximum 45 minutes. Maximum 45 minutes. These stories done. Born newly. Okay. Okay. I don't do sample questions. But you come up with your inputs. If majority coming in the right input, now you come up with your inputs and I will create a poll and we'll discuss. People who enroll for the March, right? We'll talk with them and this is the way. I don't change the way, but you can suggest your points. So then we can do a effective class. So I think now class very effective for my point of view. I don't know that when we were going for revision classes. So not they are doing a bright revision actually. They are just doing 2-3 questions and they are just explaining the stuffs. But I think I can do more. But the problem is we need more time. So when the time is getting more, people also not that much engaging well. So that's the thing. So I think this way is so much nice. What you do now, give your comments and feedbacks. That's very important. Students comments and feedbacks are important. Even though I do like this, who knows, if you don't understand, no use, right? I brief the entire lesson within 1 hour. If you don't understand, there is no point of doing a revision, right? There's a problem that side also. We can't go in deep and we can't explain because then it will become a theory class. So but quickly all the important points we want to explain for the students to understand. I'm thinking that is happening. I don't know how many of you really understand. No, I don't know the story. But better you come up with some feedbacks, then we can get me. So I think now don't need to worry. It's a really big hard work in my side. But when you work with me for continuously, not coming 1 month and not stopping the classes, and again when exam come closer, again joining, not
that won't work. uh, if you continuously, if you join for these 7 months, we can do a big thing, right? You will definitely, you will get a confidence, no doubt that you will get a good confidence when we are doing past papers, we are doing questions, we are revising, everything is in your touch. Sometimes you will get a big confidence. I don't know how many classes they are doing like this. I think can't do. Our side's a big loss, in my side's a big loss. But for my, but satisfaction and my growth, I am doing this. Okay, the story. So you also study, you also ask doubts on it quickly. I can't respond actually, because you understand my schedule today. Now I am fasting. Just because we are fasting, can we skip class? We can't skip classes now from morning 10 to 10 to 2, 2 to 6. This is 7:30 to 7:45 to 11:15. So therefore we have to work. So then I don't also have time to message you and everything. After night only I can have a time to what put some messages. So therefore we want to think every side also. But I reply as soon as possible. So then you guys create a group also, create a group, and if you don't like to ask questions in my group, you guys talk and you guys create a group, and then if you want I can join your groups and we can discuss the questions. Then everyone can get the idea. That is the best way. Okay, there are many people who scored very well, who studied hard in the last time and who achieved A passes. There are many. Now getting in is not that much very big thing nowadays. Okay, now generation is very good to catch quickly. They have a very good capacity to catch everything quickly. So therefore I think your generation people can catch everything so quickly, right? So it's all about your focus. If you are really focusing well, if you are really this 7 month, if you are managing very well, I think going for B and capital A result is not that much difficult for you. Because not for you, not difficult for you. Okay, you will understand that story. So yes, okay. So then I will going to the Bernoulli's equation. Before going to Bernoulli's equation, you should understand three stories. Okay, pressure story, you know what is kinetic energy per unit volume, what is potential energy per unit volume. That story you want to understand. Okay, right? I will raise the boat. Then Bernoulli's equation. I will talk only one, two applications only. I can talk. And also this revision people. Now I want you to put a message. I noticed there's an issue with what the course. Course means now if you have enrolled for that bundle 25 theory, 25 revision plus, then you get access for 26 theory. Ni. Some of you have told that even you click 26 theory, you can't access the recording, so you can't join the Zoom sessions. If you are facing any issue, please let me know. Then I can talk with the website people. Only two, three people told me there's an issue, sir. Even though even though I click the 26 theory, that course, I can't get the recordings or anything. If you are facing anything in your joining through Zoom or whatever, please put a reply. Then only I can forward that to the Ace Academy, the team. Okay, if you are facing something also, please let me know. Next story. Next story. Right now. Okay, last few minutes. Last few minutes. Last few minutes. Shall you drink some water and come? Okay, give me 2 minutes. I'll drink some water and come.
First, you should understand what is kinetic energy per unit volume. So, if I brief it, okay, give me 1 second. So, brief it. Now, you all know kinetic energy very well, half mv squared equation. This is kinetic energy per unit volume. Kinetic energy. This story is okay. This per unit volume. Kinetic energy per unit volume. Okay. By the name, you can understand what the story says. Just consider a fluid flow. When you consider a fluid flow, now this fluid is flowing. You can draw some streamlines also. This fluid is flowing like this, right? That liquid is moving. Okay, I have drawn 2 3 streamlines also. Now, when you consider, look here, if I consider this part of the, if I consider this part of the fluid, let's say the velocity of the fluid at this part, when you consider very small part, this part's volume is capital V dash, okay? This part's volume is V dash, right? So the mass of this fluid part is simple m. Velocity of this fluid part is capital V. Now V dash means volume, V means velocity. Mass simple m. So then what is kinetic energy per unit volume? When you consider V dash, volume, when you consider V dash volume of the fluid, its kinetic energy is half m V squared. Am I correct? When you consider V dash volume, 5 meter cube volume, kinetic energy of that part is, kinetic energy of the 5 meter cube volume is half mv square. When you consider only 1 meter cube volume, 1 meter cube volume, what is the kinetic energy? Half mv squared over V dash. Am I correct? So this is we call as kinetic energy by unit volume, right? So now simple m means, simple m means rho into V. Because mass over volume is density, mass over volume is density. So simple m means, you guys know, simple m means rho into V, rho V. So therefore, when you, instead of simple m, when you substitute rho V, you will get, keep in your mind, kinetic energy per unit volume means, if you substitute simple m as rho V, this V means velocity, rho V dash, okay? I mistakenly do something. M means rho V dash, this V dash cancel out, okay? You can write down kinetic energy per unit volume. Keep you, kinetic energy per unit volume means, keep in your mind, half rho V squared. Half rho V squared. Now I showed you the derivation also. Kinetic energy per unit volume means, keep in your mind, half rho V squared. Half rho V squared. Okay. Now likewise, you should know what is potential energy per unit volume. What is potential energy per unit volume? What is potential energy per unit volume? Potential energy per unit volume. Now same story. Same story when you consider a fluid. Okay, careful listen story. Yeah? Again, I draw a fluid. That fluid is flowing like this. Now this is the ground. So we know, we learned gravitational potential energy. We learned those stories in work energy power.
This is the ground. This is the ground. Then we know what is the potential energy at the ground. We take it as zero. Potential energy is zero. This is ZPL, zero potential level. Now, if I consider a fluid flow, this part of the fluid, its mass simple limb, its volume is V dash. The vertical height to this volume of the fluid from the ground is, let's say, simple h. Simple h. Then what is the, when you consider this V dash volume of the fluid, when you consider V dash volume of the fluid, potential energy is what? mgh. When you consider 1 meter cube volume, what is the potential energy? mgh V dash. Right now here you can't see, I think. When you consider 1 meter cube volume, what is the potential energy? mgh V dash. Now V dash means, you know, V dash means you can write on m over O. V dash means, now if not you can write on m means what? M means, you know, m means rho into V. Rho into V dash. M means rho into V dash. Finally, you are getting potential energy per unit volume means, if you do it, potential energy per unit volume means, remember, rho gh. Now I should explain only these two equations, but if I explain, I know most of you don't know how this came. That's why I did a small derivation. But in here in our class, we can't do any derivations because we can't waste time for the derivations. Then we don't have the time to finish the 2 chapters per day. So, but keep in your mind, is the potential by unit volume. Now, Bernoulli. Now, based on these two stories, we can talk about Bernoulli. Bernoulli says very simple story. Bernoulli's equation. Bernoulli's equation, the last theory part. The last theory part, Bernoulli's equation. Bernoulli is telling very small story. Bernoulli is telling Bernoulli. Bernoulli's. I don't know the spellings. Huh? I don't know spellings. I'm not good in English. Bernoulli's equation. Now, Bernoulli is telling. What is telling? He is telling a lot. He is telling in a. He is telling, right? You are going to stay with me for maximum 10 to 25 minutes. You are going to stay with me for 10 to 25 minutes. Bernoulli is telling, if the fluid is incompressible non-viscous lamina, right? If the fluid is incompressible non-viscous lamina, some conditions, incompressible, non-viscous. Non-viscous means, I think you are not familiar, no friction. In the liquid, no friction. Keep remember like that. Non-viscous, that means no friction. In the lamina. Lamina. Now you know what is lamina? Then Bernoulli is telling, I will draw a streamline. When you select a particular streamline, in the particular streamline, so there are many streamlines, but in a particular streamline, the certain streamline, when you take any points, Bernoulli is telling, when a incompressible non-viscous lamina fluid is flowing, when you take a certain streamline, any point on the streamline, right? Any point on the streamline. Now I mark any point on the streamline. Let's say pressure at I see this point. Pressure at this point, I mark it as P. Density of this fluid is rho. Velocity of the fluid at this point, let's mark it as capital V. Bernoulli is telling the summation of the vertical height, let's say simple h. Vertical height, simple h. Bernoulli is telling pressure at that point in the streamline, pressure plus
kinetic energy per unit volume at that point. Kinetic energy per unit volume means half density half rho v squared velocity plus potential energy per unit volume rho gh. This summation is a constant. This summation is a constant. This is the Bernoulli's equation. This is the most important Bernoulli story. Most important Bernoulli story. Is the most important Bernoulli story. Okay. Now, normally when we do questions, normally we take 2 points on the streamline. Sometimes we can't do, now this is only for 1 point. Now we know any point on the same streamline, this is okay, this is true. Addition of these two must be same. So we are applying this equation for 2 points on the same streamline. So when you take 2 points, I say, now, when you are writing, draw this diagram and write this equation. Again, draw this diagram and write this, the equation that I'm going to write it. I'm a bit lazy, that's why I'm using this equation. Height is h1. This point is, say, point 1. Pressure P1, velocity V1. Right, this point, velocity V2. Pressure, this point is P2. Then what? Then same density rho. Vertical height is h2. When you apply Bernoulli's equation, now Bernoulli said what? In a fluid flow, in the same streamline, when you take any points. Now I took point 1 also in that streamline. I took point 2 also in the same streamline. Bernoulli is telling addition of these three always a constant. When you consider point 1, pressure is P1, half rho, velocity is V1, potential energy per unit volume is rho g h1. This should be equal to, when you consider point 2, pressure plus half rho V2 square plus rho GH2. Rho GH2. So this is the Bernoulli story. So when we do questions, you understand how these are applied. You will understand more and more very clearly. More and more very clearly, you will understand these stories. Oh God, what the hell is this? Okay. Okay, last. Okay, Bernoulli story finished. Applications are there, but I can teach you applications. Theory wise, what else? Theory wise. Mainly that wing story only, that flying wing story only. They are theory wise to teach. Fly wing story. I teach you in questions. Okay, this is the overall. Overall is the overall. 1053. Okay, genuinely handsome now. This is the overall story now. If you know this, in questions we have to learn. Don't worry. In questions, I will teach you the applications sometimes, because everything can't teach. In applications, in the questions past, now I'm planning this. Now Saturday night, it's not a revision class time, but it's a 26 paper class time. But I want you to join for 26 paper class, and I want you to learn something from that class also. It's up to you. I will upload the recording also in the revision recordings. You watch or not, it's your thing. All right. But anyhow, I feel I am assuming all the people who enroll for revision come for the quick revision, come for the, I assuming, but you should select what you want. Come for quick revision, come for the MCQ, essay, past paper discussions, model paper writing. I'm assuming like that, and I'm doing. Okay. Now in this Saturday, I will do past paper, at least 3 past papers. I am planning to do past paper essay questions in Saturday, 7 to 11 p.m. We have 4 hours. So plan to do 3 fluid dynamics past paper questions. Then if you know these points, you will learn more in that past paper essay questions. Don't worry. Okay, that is there. That is there. And then tomorrow, hydrostatics. Mainly, I'm focusing hydrostatics. Optics, I want to do Optics I want to do, and tomorrow we'll see if I have the time. But I think we don't get the time. I think when I do the past papers, hydrostatics and fluid dynamics MCQs, if we do at least 25 to 30 MCQs, I think the time will be over. So, but anyhow, I think we covered within these 2 months. Unit 1, 2, and Unit 3, Unit 4. Some small parts we have covered. Unit 2 we almost covered. In Unit 2, the rotational motion, circular motion part is there. So I think this way we can do it, right? So no big issue with this. Uh, fluid. Did I ask you fluid dynamics crystal clear? Raise your hands. How many of you say fluid dynamics story revision is crystal clear answer? So revision. Raise your hands. Everything is okay. So this is what I want now. I can make the session bit high also now. I am summarizing and I am giving what you should know. But in addition to that, you also have common sense. In addition to this, you also know there are many stories are there. There are many sub stories. But if I start revising all the sub stories, then the problem is time is a problem. I like to revise it, but the time is the problem. But I think that this way of revision is, I think, more than enough. More than enough. But you come up with your points, put a message, give me a feedback always, because I want your feedbacks. Okay, to do this session effectively, right? To give something to you, to get something to me, to work as a team. So give your feedbacks, right? So this is the way that I'm doing. If you think that to be we want to add something to this or something to that, you tell me. I decide if really that is to be added, I will add it. If not, I don't do it. But you don't worry about that. But you give the inputs. I will take the out. I will give a put proper in order to give a proper output. Okay. So theory wise that is done. Hydrostatics, that upthrust story. When you do questions, you will learn more. Every question you will learn more. Tomorrow come for the session. Then you raise your hands and everything is very clear. So it's one thing I want to tell that now. You know that in our life, people who win are the people who manage their activities, right? The people who win are the people who manage their activities, right? Because activities in the sense it can categorize into so far your studies and your family, not any family bond also not need that much now. When we grow more and more, the responsibilities and the commitments, everything will be getting large. If you can't manage your job, your higher studies, your education, right? Even you got a degree, that does not mean you finish studying. If you are planning to go for different stages, different promotions, then you have to learn so many stuffs. Because I am giving this idea because I'm working as an engineer. Therefore, I know how this world runs. So, therefore, the people who win are the people who manage their activities. Now, here I'm also trying to manage myself. Might not that much better, but I'm managing. I am teaching. I am working as an engineer. Now I'm married. I have two families to take care, my family and my wife's family. And yes, everything. And I'm planning to start another higher study. I'm planning to do an MBA or something. That will be also started very soon. So then the time is a big problem. Not only for you. Sometimes you think, yes, now we are A-level people. So time is a big problem for us. Everyday class, everyday what? Paper class, no time to study. That's 100% wrong. That is your mindset. Okay. If you want to win, people who want to win, they find time and they manage everything. So therefore, don't make a barrier because you are having a class. You select the right three classes. If you are going for a theory, if you are a theory student, okay, first of all, I'll tell, if you have done first shy in case, and if you are doing this for second shy, I am telling for them to take only three revision paper class. Okay, a good revision paper class. Only three. Don't go For one subject, two teachers. One teacher is more than enough for one subject. Don't go two, three classes. That is my advice. If you are a theory student, yeah, you want to continue theory class, you want to go for a paper class, okay, revision paper class, okay. But when you are selecting your teachers, be very careful, right? So when you are selecting in that parameters, entertainment should be avoided, right? In a class, it's that class make you comfortable, physical or online, right? If that class make you comfortable, you don't get a fear in a class. I mean, now you should understand the class that you select. You should understand in a class. You feel that everything is okay. Something like that also is a problem, because when we learn these stuffs, you know how much of points that we have to remember. So you should select a class where actually the thing is happening, right? And you should focus. These few months, I tell that properly work. When you properly work, if you can manage going classes, if you can manage, now you should properly select the classes, and you should then then you can come up with a proper timetable or proper plan. And if you can plan your time, if you can manage your time, then definitely you win, because we all have workload. Just think, after year finishes also, when you go for a higher studies, private or abroad or whatever, then also you don't think that you will get enough time to enjoy. No, you don't get. More you grow old, more you become matured, what will happen is the happiness is getting low. That is what the practical thing. So but we all want to be successful, right? If you can manage everything, definitely you'll be very successful. So therefore, in my side, I think I am doing my best. I don't know, my best is might not be your best. Sometimes you are not satisfied or satisfied, I don't know, but I think I am doing my best. In order to make something better only, I'm asking your feedbacks and reviews. Share your feedback, reviews. I just mark the points, and if it is good or bad, you just come up with your points. Okay, so then that is there. Okay, so then in my end, I will do everything. Ask any help, I will there to help you. Ask any help, I will there to help you. uh, Come for the classes live as much as possible. If there's a class clash, in that week itself, watch the recordings and cover it. In the week itself, watch the recording and cover it. Don't judge yourself with your friends. Don't judge yourself with your friends. Your friends might be doing better than you, but every day the competition should be with you. Yesterday you and today you. Did you get a progress comparing with yesterday yourself? If yes, that means you are in a right track. And that's what I want to say. Feel free to rock. Then shall we stop and shall we sleep then? Okay. Class effective answer. Class effective. Today class is very effective answer. I felt effective, genuinely. Okay, right. It's time to go and sleep. You guys can't sleep actually. You guys should what? Take a wash or something, and you guys should revise this and prepare up. You should do past papers, or you should work and you want to sleep actually. But I can sleep. Okay, see you. Have a nice day. Have fun. Bye. We'll meet tomorrow.